9.4, graphing sine and cosine functions. So here we've got our parent graph for sine. This is our simplest possible sine function that we can graph. Okay, and what you want to remember is that when you're looking at sine functions on a unit circle, I've got a unit circle right here, we're going to be looking at the y coordinates as we go around the circle. So when I've got I've got this theta y table here, okay, not an xy table, but a theta y table. So when my angle is 0 radians, so that would be right here. So if I plugged in a 0 for theta there, sine of 0, well, at 0, the y coordinate there is 0. So that's what I'm going to get, okay? Then when I go up to an angle of pi over 2, if I had sine of pi over 2, then I'm looking for the y coordinate at pi over 2, which would be 1. Okay, and then an angle of pi, the y coordinate is 0. So that's the sine of pi. And then at 3 pi over 2, it's negative 1. And when we get back to 2 pi, it's 0 again. Okay, and these are going to serve as my critical points. So I'm going to scroll down a little bit here, and I've got this theta y coordinate grid here. Okay, so I'm going to plot these points. 0, 0 is the origin, and then pi over 2 to the right, 1 up would be right here. Pi 0, 3 pi over 2 negative 1, and 2 pi 0. Okay, and if you were to fill in some other points, we could use other angles in between and use the y coordinates. And eventually what you're going to see is that we're going to get an S curve that looks like this. Okay, now this is just one time around the unit circle, so I could keep going around, but this pattern is going to continue. Okay, so this is called one cycle of the sine function, but if I kept going around the circle and kept pulling out the y's, if I went over to the next point, this same pattern is going to continue, so I'll get another S curve that looks something like this. Okay, and I don't have room to draw all of it. I'm going to do this with a dashed line, but you're going to get another S curve to the right of that, something like that. You could also do negative angles. I could go around in the negative direction, and again, this same pattern is going to continue. So going to the left, I'll do this again with a dashed line. It's going to continue like that. Okay, so it's going to stretch forever in both directions. In my class, we're just going to be graphing one cycle. So when I say graph y equals sine theta, I would just expect students to graph one cycle of that. Okay, so this is one cycle here. Okay, so let's talk about a little bit of vocab related to this. So the amplitude is going to be the height from the midline. The midline is the line in the middle of my curve. Okay, so this would be the midline. So to start off with all of the functions, the theta axis is going to be the midline. That's right. That's a horizontal line that cuts my S curve in half. Okay, so it's going to go from the midline to the top or bottom of the curve. Okay, and I'll show you what I mean. So it's talking about the height of my S curve, but you measure it from the midline to the top. So if I take this little hill there, I could measure it right here. And the amplitude is going to be 1 unit because it goes from 0 to 1 on the y-axis. You could measure it here too, but you want to think about it's always going to be positive. The amplitude is always positive. So you can think about measuring from the bottom of this valley up to the midline. And then again, the amplitude is going to be 1. Okay, so the amplitude for our parent graph here is 1 unit. The period is going to be the length of one cycle. Okay, so looking on this particular graph, if I'm looking at this cycle, well, I'm thinking how far left and right does that one cycle stretch? And it goes from 0 on the theta axis out to 2 pi. So that means the period here is 2 pi. Okay, so for a parent graph, amplitude is 1 and the period is 2 pi. So let's take a look at a cosine curve then. We did sine, let's look at cosine. So it's a very similar process here, except when we're looking at cosine, we're going to be looking at the x-coordinates as we go around the unit circle. Okay? So at zero radian angle, our x-coordinate would be 1. At pi over 2, the x is 0. At pi, the x is -1. 3 pi over 2, it's 0. And 2 pi, it's 1 again. Okay? So now I'll plot these on a similar coordinate grid. Okay, so starting with 0, 1, and then pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi, 1. Okay, and you might think it looks kind of like an absolute value function, but it's not. It's going to be a curve like our sine curve was. So it's going to look something like this. Okay, and this is going to be one cycle of our cosine curve. If you repeated this pattern going to the left, you're actually going to see it looks a whole lot like a sine curve. So there's another cycle. I'll do this with a dashed line here. Okay, and then there would be another cycle going to the right as well with that same pattern. Okay. Here's the cycle we're interested in though, but it's good to know that it goes on, stretches out in both directions. Okay. Then the period, so this is one cycle. So the period is going to be the length of that cycle, and it's again is going to have a period of 2 pi because it goes from 0 to 2 pi. Okay. And then the amplitude, you could take any hill or valley and measure to the midline from there. So if I'm measuring right here, my amplitude is going to be 1 unit again. So it has the same period and amplitude as the sine curve. And it looks just like the sine curve. The only difference is it starts at 0, 1 instead of starting at 0, 0. Okay. All right. So let's look at this function. So now we're introducing a 3 in here. And all the 3 is going to do is it's going to change the amplitude. So if there's no number in front of sine or cosine, then the amplitude is 1. Because if there were no number, you could write it as 1 sine theta or 1 cosine theta. But here the amplitude is going to be 3. Okay? So you have to know what the parent graph looks like for sine. It's going to start at the origin. And the parent graph, the next point would be right here. But since this has an amplitude of 3, that means that first hill is going to be 3 units high. So I'm going to go up 3 units, then to the middle, then down 3 units, and back to the middle again. And there is one cycle of my sine function there. Okay. When we have a negative out front here, what this is going to do is it's going to give me a reflection over the theta axis. Okay. What we're going to be doing, we're going to take the x-coordinates going around the circle, but then we're going to take the opposite of those x-coordinates because of the negative. Okay. So the cosine, the parent graph for cosine would start up here, but since we're reflecting over the theta axis, this negative cosine is actually going to start down there. Okay. So remember the cosine curve looked like a big valley. So if you flip that over the theta axis, we're going to get a big hill instead, something like this. Okay? So that's what a negative is going to do in front. Okay? Now on this one, we've got -2 cosine theta, and it's understandable if you would look at this and say, oh, the amplitude is -2, but the amplitude is actually always positive. So what you want to do with this negative, think about this separately. This is going to give me a reflection, so it's going to flip everything upside down. And then the 2 gives me my amplitude. Okay, so this is cosine again. cosine you would usually start above the amplitude is 2, cosine you would usually start above, but the reflection means it's going to start down here. Then we'll go to the middle, top, middle, and bottom. So this is, again, a hill instead of a valley because of the reflection, and then the amplitude means it's going up and down 2 units from that midline. Okay, so on this next example, we've got a 2 here, which is going to give us the amplitude. So the amplitude here is 2, but then we've also got this 3 to contend with, okay? So this coefficient is in a different position. It's in between sine and theta. And when you've got a coefficient in between sine or cosine and theta, this is going to be your k value. So in this problem, k equals 3, okay? And that's going to give me the period. It's not the period itself. There's a little formula. For sine and cosine curves, the period is going to be 2 pi over k. All right? So for this one, the period, 2 pi over k, well, it's 2 pi over 3. And then I just want to make sure that's reduced, and it is, okay? So my period is 2 pi over 3. So graphing these, the first thing you want to do is find the amplitude and period. Okay, we did that. Now I'm going to sketch the curve using the amplitude. So I'm just going to ignore the period for a second. So, all right, I've got a sine curve that's going to start at the origin. All right, and then the amplitude is 2. So I'm going up 2 units here, then to the middle, down 2 units, and to the middle. Okay, and then I can draw the actual curve in. So for all the problems I give in my classes, I always have the scale on the y-axis as 1 tick equals 1 unit. But that's not going to be the case on the theta axis. Okay, so hey, we did step 2. So the last step here, I want to scale the theta axis using the period. Okay, this is 1 cycle of my graph, and the period is the length of 1 cycle. So I can think, oh, this is starting at 0, and then it's going to take up 2 pi over 3 units in total, this whole S-curve, okay? So that means this 4th tick out, where this cycle ends, is going to be 2 pi over 3 units, okay? And then we have a frame of reference for the theta axis, and you could, from there, figure out how much the other ticks are worth. For me, it's fine if you just label that 4th tick with the period every time. And that's kind of taking care of our horizontal and vertical stretches, because if I just give you problems where the amplitude isn't that big, so we can fit everything nicely with not too many ticks on the y-axis. But that's hard to do that on the theta axis because things can get really stretched out or really squished, and then it's really hard to see what's happening on problems like that. Okay? All right, so next up, let's find the period of these following graphs. So remember, the period is the length of 1 cycle. Okay, so what I'm doing here is I'm thinking, okay, if I'm thinking of this as the beginning of my cycle, that's 1 hill, but that's not a whole cycle because I just have a bunch of hills if that was the cycle. So I need a hill and a valley. So this is where that particular cycle ends, and now I can see it goes from 0 to pi over 2. So for this one, the period is pi over 2 units. Sorry about the bell there. Okay, so let's do the same kind of thing on this one. If I'm starting a cycle here, okay, there's 1 hill, there's 1 valley, and when we get back to the theta axis there, that's the end of that, and I can see, okay, that goes from 0 to 8 pi, so that means the period is 8 pi units. Okay,